Magnesium, also referred to as Mg, is the 12th number in the periodic table. It has an atomic mass of 24.31, being made up of 12 neutrons and indeed 12 protons. Magnesium is also constructed of 12 electrons, and the distribution of electrons is as follows. In the first shell, there's 2 electrons. In the second shell, 8 electrons. In the third and last, 2 electrons. Magnesium belongs to the second group in the periodic table, which is the alkali earth metals. Some elements in this group are calcium, beryllium, and barium. The Scottish chemist Joseph Black first discovered magnesium in 1775. He was quite an important man, indeed the chair of chemistry at the University of Edinburgh. However, magnesium was first isolated by Sir Humphrey Davy 33 years later, in 1808. Its industrial production first began in 1886 in Germany, and it is the 8th most abundant mineral found in Earth's crust and the 4th most abundant mineral in seawater, after sodium sulfate and chloride. Most of magnesium comes from seawater, where it exists in the form of magnesium chloride, although it can also be found in natural minerals such as dolomite and magnesite in the form of magnesium oxide. Either chloride or oxide, magnesium needs to be transformed into its pure form, and there are three ways to do so: the electrolytic method, the thermal reduction method, and the pigeon method. The electrolytic method is based on mixing seawater with lime in tanks. This will then precipitate magnesium hydroxide to the bottom of the tank. Later, it will then be filtered and mixed with hydrochloric acid. The end product will be exposed to electrolysis, and as a result, we produce magnesium metal. In thermal reduction, dolomite, magnetite, and other magnesium ores are broken down through the use of reducing agents. This combination is then heated up in a vacuum and will then be formed into magnesium vapors, which will subsequently condense and become crystals. The crystals are then melted, developed, and poured into ingots for further treating. The pigeon method is the most common method regarding the production of magnesium. The reason for this is that it is extremely easy to operate and has a low capital cost. Nevertheless, the process is high in energy consumption but has low productivity. In this process, magnesium is collected by using a condenser on the outside of a vacuum. High significance of magnesium can be achieved from the condenser. This will occur as the vapor pressure of impurities that might be in magnesium are really low inside the conditions of the tank. Magnesium is a micromineral, which unlike most trace minerals is needed in large amounts by the human body. In fact, the average human body contains about 25 grams of magnesium, making it one of the 6 essential minerals that must be supplied in a diet. Magnesium enters the body through food and tropical applications. Inside the body, it aids almost every function and tissue in the body. It supports the immune system, prevents inflammations associated with cancer, keeps bones stronger, and the blood pressure normal, increases the heart health, and can prevent the risk of heart attacks. 60% of magnesium is found in our bones, the remaining in the body tissues, and only 1% in the blood. It is estimated that adult men should take around 400 milligrams of magnesium, whilst women only 300 milligrams of magnesium daily. Nevertheless, this increases to 420 and 320 after they reach the age of 30. Many studies have done to prove that magnesium is beneficial for our health. In fact, Harvard University stated that high daily consumption of magnesium could reduce the risk of developing diabetes by 33%. Furthermore, other studies have proved that magnesium can help cover depression crisis and migraines. Another study published in the American Journal of Clinical Nutrition demonstrated that higher intakes of dietary magnesium are associated with a lower risk of colorectal tumors. Results indicate that for every 100 milligrams increase in magnesium intake, the risk of colorectal tumors decreased by 30%, and the risk of colorectal cancer was lowered by 12%. Researchers noted that magnesium anti-cancer effect can easily be related to its ability to reduce insulin resistance, which can positively affect the development of tumors. Nevertheless, studies have also suggested that nearly half of Americans aren't consuming enough magnesium. According to Asian Minerals, less than 30% of U.S. adults consume the recommended daily allowance of magnesium, and almost 20% get only half of the daily magnesium they need to maintain a healthy life. Food that provides 20% or more of the daily value are considered to be high sources of a nutrient. To complete the natural intake of magnesium, there exist supplementary sources of this mineral in a variety of forms, basically either pills, powders, or creams. The ones that dissolve in water provide a higher body absorption. Additionally, magnesium is also utilized as the main ingredient in some laxatives and also in remedies for heartburn and for upset stomachs to combat bad digestions. Indeed, magnesium is used to combat multiple diseases such as constipation, headache, leg or muscle cramps, acne, or to increase energy. In the early days of photography, the only source of light was the sun. Therefore, photography depended on long days and good weather. It was fairly obvious that artificial light would be crucial in order to develop the market. The development of artificial light would mean not depending on sunlight anymore, and that pictures could be taken in places where natural light was not sufficient even on the old days. In 1862, Edward Sundance became known for being the first chemist to create artificial light using magnesium. He created what became known as the magnesium wire. The wire was fairly expensive, however, after an extremely successful demonstration in February in 1964, where a photograph was pictured in a dark room in only 50 seconds, the product proved to be ideal for photography and became extremely popular. Furthermore, the usage of the wire was rather simple, as it worked by burning a wire or ribbon into trapper or clockwork lamps with reflectors. In 1925, using the idea of magnesium lamps supplied by oxygen pulled vertical red magnesium electronically in a glass globe. By 1929, the backlit became the first true flash bulb made from aluminum foil sealed in oxygen. The Hauser company, using Johannes B. Osm's patent, produced it in Germany. Flash bulbs were a huge step forward. They were little, were extremely easily fired electrically, and really powerful. Moreover, the technique was really safe, especially when compared to the inventions used before flash powder. Due to the high quality of the invention, the mass market of the camera soon fitted with flash guns or synchronizers. This was a tremendous technology improvement for photography, and by the 1950s, bulbs had replaced flash powder on the market. Also, many versions of flash bulbs were released with the purpose of making the use of the flash more convenient for a new or amateur user. Magnesium naturally occurs in three stable isotopes, magnesium 24, 25, and 26. However, there are 19 radioisotopes that have been discovered ranging from magnesium 19 to magnesium 40. Magnesium 24 has 12 neutrons, an actual abundance of 78.99 and a half-life of stable. In the case of magnesium 25, it has 13 neutrons, an actual abundance of 10% and a half-life of stable. Lastly, magnesium 26 has 14 neutrons, a natural abundance of 11.01, and also a half-life of stable. Magnesium isotopes 25 and 26 are used to study the absorption and metabolism of magnesium in the body. Further, they are also used for the study of heart diseases. Magnesium 25 is also used for the production of the radioisotope sodium 22. Sodium 22 is used for medicine and other applications. They are used as tracers to follow the path of sodium in a person's body. A tracer is a radioactive isotope which presence can easily be detected within a human system. Now we have come to the most interesting part of my presentation. Why should anyone buy magnesium now? There are three very important reasons why magnesium is a good business. First of all, magnesium is a vital component of the human body, and hence it is going to be increasingly needed as the world population is steadily growing year after year. It is estimated that by 2050 the world population will reach already 10 billion people. Therefore, we can only expect the magnesium need to strongly grow. In fact, and this is my second reason, this is already happening. According to Minor Metal Trade Association, the world production of magnesium is estimated to have increased from 499 TK in 2002 to almost 905 TK in 2012, with an annual growth rate of 6.1%. There is only one constraint: we better get along with the Chinese. The production of magnesium metal is mostly related to 10 countries, China being the primary denominator of the industry, having an output of 680 TK in 2012, making 75% of the total production of magnesium, having increased from 200 TK in 2001. Last but not least, this is a fantastic moment to buy magnesium. As displayed on the graphs, the price of magnesium since 2008 has drastically diminished from $6,000 per kilogram of magnesium to around $2,000 due to the fact that the price of commodities have shrunk as a result of the global economic crisis and because China is developing slower than expected.